So hello friends, in this video we are going to discuss our Codechef's Starter 154. So basically our first problem is calorie limit. So in this problem statement, we have been given that we have to means Social is a diabetic patient over here. So he is allowed only to eat at most k calories in a day. However, he likes to eat sweets a lot. So basically we have been given k as our at most k calories. Means Social can eat at most k calories over here in a day. Also, there are n sweets in front of it. So the ith sweet has a calorie count of AI. So basically, here we have been given a K as our calorie limit. K as our calorie limit and N as our number of sweets. So basically, the ith sweet has a calorie count of A. So the guy means the Sushil wants to eat the sweets in order, that is, he starts from the first sweet, then second and third, and so on. If eating the ith sweet will take over his daily calorie limit, he will not eat it. He will also not eat the further. Basically, over here we have to just return the maximum number of sweets the social can eat without exceeding his calorie limit. So means we have to return an simpler integer over here. So let's try to understand it with the help of an example. So for example, we have been given the number of sweets as 4. So 4 are the total number of sweets and the calorie limit over here is 10. And the array over here is given with the respective calorie limits of each sweet. So Sushil will start eating the sweet from here. So his calorie limit is now 5. Then he will eat this sweet. So now it is 7. And now another sweet. So it is now over here, it is 12. His calorie limit is 12. So basically over here, the calorie limit 12 health is what? It is greater than 10. Means it is exiting the limited means calorie limit over here. So means he can't eat the this sweet over there. Means the third number sweet. So if we remove this sweet over here, so we have total number of sweets as 7, which is what less than 10. So over here, 7 is less than 10 means our answer will be 2 over here. Simply our answer will be 2 means the maximum number of sweets that Sushil can eat is 2. Simply it will be 2. Let's try to understand with another example. Let's take an edge case over here like 3 and 10. Basically the calorie limit over here is 10 and you have been given 3 sweets 11 whose calories are 11, 1 and 11. So basically over here it's not 11, it's basically 1. So over here the first sweet has calorie limit of 11. So calorie is over here is 11. So we will check over here that 11 is less than or equals to 10. So basically 11 over here is greater than 10. Simply it is greater than 10. So our answer will be what? Our simply answer will be 0 in this case. Means according to the question, according to the question, if the ith sweet would take him over his daily calorie limit, he will not eat it and also not eat any further sweet. Means if he stop over here, he will not eat the further sweets also. So means we have to just return the simply the answer means the count of the sweets he have ate up till now. So our answer will be 0 means he is not able to eat any of the sweets. So over here let's discuss the approach over here means how we have solved the problem. Simply first of all I have maintained two types of count variables over here. Like for example we can say hey I have let's show you the solution over here. Okay, first for example C is my list of sweets over here and D and E are basically the count variables. So over here I have assigned D is what equals to 0 and also E is equals to 0. Let's suppose that D is what total calories over here and E is I have made at sweets count. So I have run the for loop over here. Basically, I have run the for loop from 0 to A. A is what the sweet count over here. So for I in range A, over here I have run the for loop. So basically, if for each element I am checking it now, means from for iteration I equals to 0 over here. Let's suppose take an example over here. Let's take an example. So 45211. Okay. Basically, we have taken example of 4 is number of sweets and 5 is the calorie limit. And these are the number of sweets given over here means with respect to calories. So for iteration I equals to 0 over here. For our first iteration, basically the number of sweets is 4 over here. So our for loop will be running from 0 to 3 only. Means 0, 1, 2, 3. So over here, for I equals to 0, we will check that our total calories plus 2 is what greater than or equals to 0. D and E are what 0. Okay, they are simply 0. So over here we will see that D plus 2 is what greater than and the 5. 5 is what calorie limit. So means 0 plus 2 is what greater than 5. We will check over here simply means we will check that if 2 is greater than 5. If it is so, we will just break over here. Okay, just simply break over here. So over here, as you are able to see that 2 is what not greater than 5. So we will simply add it. We'll just simply do what? Add it to the D. Means our D over here will be 2 now. Okay, and our E will be incremented by 1. Means Sushil has 8 one sweet over here. Okay, done with it. Now iteration number 2. Means I equals to 1 over here. We will check. D plus 1 is what greater than 5. D plus 1 is what greater than 5. Over here, D is what 2 plus 1 is what greater than 5. Means 3 is greater than 5 over here. We will check that if 3 is greater than 5 or 3 is what it is not greater than 5. So our D will be now equals to 2 plus 1. Okay, our D will be equals to now 2 plus 1 which is 3 and E will be equals to 2 means Sushil has 8 2 sweets over here. Now our third iteration means I equals to 2. We will check that if our D is what? D plus means 1. So 3 plus 1 is what greater than 5 means 4. We will check that 4 is greater than 5. So it is absolutely not. 4 is not greater than 5. So our D again will be incremented by 1 means it will be 3 plus 1 which is 4 over here. Okay, it is 4 and our E will be what? E will be now 3 means Sushil has 8 3 sweets now. Now our last iteration means fourth iteration I equals to 3 over here. So we'll check that our D is what? Our D plus 1. If it is what? Greater than 5. So last one is only one only. So basically D is over here is 4. So basically 4 plus 1 is what? Greater than 5. It is absolutely not. Okay. It is absolutely not greater than 5. So basically our D will be now 4 plus 1 which is now equals to 5 and our E will be also equals to 4. Okay, means we have completed with all 4 sweets. So basically we have left with no iterations over here. So just simply print E over here means our answer is what? 4 over here. Simply 4. So in this way we have just solved this problem over here. Okay, simply move on to our next problem statement. Our next problem is add one or two game. Okay, so basically it's a very simple problem. So let's discuss it. Alice and Bob are playing a game. So basically there is an integer x over there which is initially 0. So as we know that x is always 0 over here. Okay, means always in the sense in the start of the game it is always 0. So Alice and Bob can choose to increment x by either 1 or 2. Means x will be either incremented by 1 or it will be incremented by 2. Okay. So basically, in this two types of operation can be performed. The game ends as soon as x is greater than or equals to n. So basically, the game ends in which condition? When x is greater than or equals to n. So when the game ends, Bob Bob wins when x is what equals to n. So the alternate way is what? The alternate way is when the Alice wins. When does the Alice wins? Alice wins when the x is greater than n. Okay, with this simply two conditions we are able to see. So Alice is approaching the first in the game, and if both players play optimally, predict the winner. Optimal game over here is optimal game we have been seen means greedy. We can simply say greedy. So basically, what is greedy over here? Basically, Alice over here will play such in such way that she wants to make Bob lose. Okay, and Bob will play in such a way that which he wants to make Alice lose. Means both players will play optimally. Means both players are playing greedily. Both want to make each other lose. So let's discuss the means example over here. It will give a clear idea. So our first example is one only. So basically over here, we will let's see that Alice will increase x by 2 over here. Okay, our one is what? It is simply n over here. Okay, means it is n. So we have to make x is what? X is greater than equals to n. Okay, so basically over here, our n is 1. So in this case, we will check that how in which way can this be increased. So Alice will increase it by simply means in first move only. It will increase x by 2 over there. Okay, it will simply increase x by 2. So by increasing x by 2 means it will be greater than n equals to 1. Okay, means over here 2 is what equal greater than 1. So in this case simply Alice wins. Okay, but for n equals to 3 over here, let's see what will happen if n is equals to 3. So in this case over here, we have to our x is what 0. So now first Alice turns comes. In Alice turns our x will be now 2. Okay, it will be simply 2. Then Bob's turns comes. Okay, so our x will be 2 plus 1 which is 3. So basically it is simply x equals to what 3 now. It is simply equals to n equals to 3. Means 3 is equals to 3 over here. So in this case Bob wins. Okay. But let's see that if there are two conditions. Alice can increment the means number by either 1 or 2. Let's see that if it increase the x by 1 over here. Okay. Means Alice if it increase the x by 1, so our x will be now 1 over here. And what if Bob increments the x by 2 means x will be now 3 over here means 1 plus 2 which is 3. So in this case also 3 is what equals to 3 only. X equals to 3 is what over here n only. So basically in this case also Bob wins. Okay. So in what we are able to observe over here, let's take an example, simple an example. Let's suppose we will take 6 over here as our number. So first of all, x is 0. Alice turns comes. So our x will be what? 2 in this case. Means it has incremented the x by 2 in this case. Okay, then Bob's turns come. Our x will be incremented by 1, which makes it 3. Okay, let's suppose again Alice turns comes. It incremented the x over here. It just simply incremented the x over there by 2. Means x plus 2 over here. So it will be what? 3 plus 2 which is 5. And then Bob's turns comes. It will increment again x by 1. For example, it will increment x by 1. it will make it 6. So basically over here our x is what 6, which is also equals to n equals to 6. Okay, means both are equal over here, and we know the condition that if the x is equals to n, simply Bob wins. So in this case, we are able to see that if we take any of the number from 2 to 1000 infinite, we can say 2 to infinite, we can take any of the number. In each case, Bob only wins. In each case, Bob will win. But in the case where 1 is only given, okay, but there comes an edge case. What if n equals to 1? In this case, in first move only, Alice will increment x by 2, making it 2 only. So basically 2 is greater than 1. So in this case, what? Alice wins. So there is only one condition only. There is only one condition in which Alice can win, which is the n is equals to 1 over here. In all other condition, Alice will lose only. So this is my code over here. So basically this is my code. I have taken n as a over here. So please try to understand. If my a is not equals to 1, simply print Bob. Okay, means the n over here, or we can say a is not equals to 1. So we have to simply print Bob. Means Bob wins in all conditions. But what if the n is 1? So in this condition only Alice wins. Okay. So this was the approach for this question over here. Add one or two game. So basically this was the approach. So now let's discuss our next problem statement over here.